Hi, my name is Andrew Knight. Today I'll be giving a talk on why computers will never be conscious. Not a technological problem, but that fundamentally physics and the nature of the universe will prevent computers from ever being conscious. A little about me. I got my degrees in nuclear engineering from University of Florida and MIT, and then a law degree from Georgetown. I have 17 patents on a variety of technologies, and I have taught both physics and mathematics at the high school and college level. I say that not to assert that what I'm about to argue is correct, but rather that often people will not even consider an argument unless the person making it has at least some minimal level of qualification, which I hope that I would meet for this talk. So what are my motivations for making this video? It's really my first foray into YouTube in general, except for some videos I put up years ago on how to write a patent application. But my motivation is first and foremost to learn the truth about the universe. And there's very complicated, difficult questions that people have been struggling with for millennia, but especially in the past century or so, since the discovery of modern physics, relativity, and quantum mechanics, that have caused a lot of these deep problems to arise again. And I just want to know the truth. Maybe I never will. Maybe we as a society never will. But I'd certainly like to try. Another motivation is for putting up this video is that there are very few people who are seriously, academically, looking at the relationship between physics and consciousness. Sort of ironic because when quantum mechanics was first discovered, certainly Heisenberg and Einstein and Bohr and lots of the greats wondered about these deep philosophical questions, and I just feel like the question has gone by the wayside. It's almost heretical at this point to mention the word conscious and physics in the same sentence. So as a result, there are very few people who are looking at that relationship between physics and consciousness. I want to connect with people who are working on this, collaborate with them, just basically make contact. There are a few people that I know of who are working on this, and I have begun that process of making those connections, but I'd like to find more. And I'd also like to get some useful and constructive feedback on the contents of this video and future videos. And ultimately, I would be very interested in doing PhD work with the right advisor and the right university program that is interested in the relationship between physics and these really difficult problems about free will, quantum mechanics, cosmology, the arrow of time, and statistical mechanics, and relating to why was the beginning of the universe so low in entropy. That seems to be a really difficult but important question. So let me start off with some of the problems. Well, before I do that, let me just talk a little about fundamentally the physics of consciousness. So I make this assumption, a very reasonable assumption, that consciousness is a fundamentally physical event, that consciousness arises from a physical state of matter. So what I've written here is there's some, I call it some S1, some first physical state from which some later conscious, well not later, some conscious state C1 arises. And notice that I have this little star here. And what I mean by that is really S1 might be a set. It might not just be a single physical state. It could be a set of states, all of which produce some conscious state as a result. And so what physicalism says is that whatever conscious state I'm in at this moment has to be the result of some underlying physical state of the universe. And now what do we mean exactly by physical state? I don't really, I don't think it's appropriate in this video to get into that because we don't really know what that means. I mean, classically it might mean the positions and momenta of individual particles, but of course we know that the classical description is inadequate now that we know about quantum mechanics, so maybe the physical state of the system might be the wave state, but of course that's really kind of complicated and weird. The wave state of a system could be the superposition of mutually exclusive pure states all at the same time, but then it seems to collapse into one of those states upon measurement, and that causes the measurement problem. I'm not going to get into that. So the point is, let's just say fundamentally, I'm making the assumption that whatever conscious state I'm experiencing right now has to be the result of some underlying physical state, and there may be more than one physical state that causes that conscious state. So one of the biggest mistakes that many people make about the relationship of physics or science to consciousness is the assumption that consciousness is algorithmic and that basically the brain is nothing more than a computer. We know that it's not a digital computer. It's far more complicated in that, with the parallel processing and all kinds of analog issues. But the point is that many people think, maybe most people think, that the brain is nothing more than a computer. Now just realize, though, that this is an assumption about physicalism, that actually physicalism doesn't require that assumption. It doesn't make that assumption. We've simply assumed that. In fact, Roger Penrose, I'll have a list of a couple references at the end of this, but Roger Penrose actually is famous for being very blunt in saying that consciousness cannot be algorithmic, and he gives a very interesting argument for why that is the case. But in any event, just realize that that is an assumption. We don't know whether the brain is just a computer, and we don't know whether consciousness is algorithmic. The next mistake is assuming that a conscious state can be repeated or copied. All we have to do is just copy the brain, and we'll get another version of the same conscious state wherever we make that copy. And keep in mind that, again, that is an assumption that is not required by physicalism, but I think it's a very common assumption, the thought that if you just, were somehow able to photocopy a brain somewhere else, then whatever consciousness arose from the first copy has to arise in that second copy. Not everyone agrees with this. Scott Aronson's paper, reference at the end of this lecture, he actually gives an argument for why that might not be the case. And also, another question might be, well, how good a copy does the copy of the brain or this underlying physical state have to be in order to replicate the exact same conscious state? And if the answer is just kind of an okay copy, well then maybe you can copy a conscious state. But if the answer happens to be, for whatever reason, the copy has to be so good, it has to be an exactly perfect copy, well, now we know that that can't be done because of the quantum no-cloning theorem, which essentially says it's you can't copy a quantum state and make more than one copy. You can kill one copy and make another, but you can't create two copies of the same quantum state. So as a result of these assumptions that consciousness is algorithmic, or at the very least you could copy a brain and make the same conscious state elsewhere, you get all these, you might call them philosophical problems, but they're not just philosophical problems. They're actually scientific problems because they have answers, and I believe that they can be empirically tested. So one problem is what's called kind of the duplication or teleportation problem. and Dr. Penrose talks about it in his book, The Emperor's New Mind. And this is just simply, what would it be like if, we could teleport, if I could teleport myself to Mars? And the way it's done is that, on Mars, first we scan my brain somehow and get the exact physical state necessary to replicate my conscious state. And then on Mars, we recreate that state, and then at the same time, we I guess, destroy or kill the one on Earth. And this seems to, it would seem that I would then feel like I teleported to Mars, right? The physical state that created my consciousness on Earth no longer exists, but there's an identical one on Mars that creates the same conscious state, so it would seem like I kind of just teleported my brain. It's different atoms and so forth, but it's the same physical state. But then what happens if whoever was supposed to destroy the copy on Earth was on strike or wasn't paying attention? And so now there's two copies, and the question then becomes, well, what do I experience? What do I, as a conscious entity, what do I experience? Do I somehow experience both of those states of consciousness? Do I experience one? How is it chosen? So that's a problem. The next problem, well, there's lots of them. I'm just going to mention a few of them. The next problem is simulation problem, and that's just this notion that, well, if consciousness really is algorithmic, then, not only can you, run it on a computer, but you could run it on lots and lots of computers. And because computers it's a lot cheaper to create a computer than it is to create an entire universe, then it is essentially infinitely more likely that that I am a simulation right now than the likelihood that I am actually physical and that the universe created me. So it's this weird simulation problem where there could be, a million or infinitely many instantiations of me right now, or of you, or of any conscious entity, and what does that feel like? So that's another problem. Another problem is it's a philosophical problem of self-location, and Adam Elga presents this interesting problem of Dr. Evil. Dr. Evil tells me that he has made 1,000 copies of me, and that he's going to torture them all unless I give him $1 billion or something. And Adam argues, Dr. Elga argues, that I should take that threat seriously, the likelihood, the very good likelihood that I am actually one of those copies, and therefore Dr. Evil should be paid. And that's a problem of self-location, meaning which one is the real me, whatever the heck that means. And that's a real problem if we can create lots of instantiations of the same conscious state. And then another problem is this idea of a Boltzmann brain. And that is simply that, okay, so let's say we never become capable as a society of creating, of putting consciousness onto a computer, or of ever copying a brain perfectly to create another brain state, fine. But essentially, quantum mechanics says that anything that is not forbidden is mandatory. It's going to happen at some point, given enough time. No matter how unlikely something is, it eventually will happen, given enough time. And so the Boltzmann brain idea is that, so what is my brain made of? I don't really know. I imagine there's probably some silicon and oxygen and nitrogen and lots of carbon. And there's not very many of those atoms floating around in free space, but every once in a while there is. Some supernova happened, nearby, and so there's a couple of whatever. The point is that as unlikely as it seems, eventually, given enough time, there's going to be some random collection of atoms that exactly matches the configuration of atoms in my brain and creates my brain for a second or a fraction of a second or a year, I don't know. And so essentially, if the same conscious state arises from that underlying physical state, then what would that feel like if that happened? I mean, I may be dead and gone for you know, a billion years, and then all of a sudden my brain pops into existence out in the middle of nowhere. What would that feel like? So that's another problem that's addressed by this talk. So what I'm going to propose is a theorem, meaning just a statement that I'm going to attempt to prove, that I call the single stream of consciousness theorem. I'll talk a little bit later about the meaning of the words conscious and so forth, but let me just say what the theorem is. A conscious entity, a person, cannot experience more than one stream of consciousness from a given conscious state. So it doesn't say that a conscious entity will experience a stream of consciousness. Just, you know, if an entity is conscious and it experiences a stream of consciousness, then it can experience more than one from that same state. Now, it kind of seems almost obvious to some degree. It seems obvious in the sense that we've never had an experience of what it's like to have multiple streams of consciousness at the same time. You know, what would that even feel like? When we're in deep sleep, not dreaming, there's no consciousness there. So you know, we can imagine what it's like to not have no stream of consciousness in a given period, but to have 2 or 5 or 10 streams of consciousness seems weird. But that's not a proof of the theorem, just that it seems weird. Maybe there are higher states of consciousness that we don't know about. So I wanted to go ahead and actually prove this theorem. I'm going to do it using special relativity. And basically what I'm going to do, and I'll do this in the next slide, is I'm going to consider 2 instances of a given conscious state that are space-like separated, and then I'm going to also consider 2 instances that are time-like separated. Now, if you're not familiar with special relativity, these are relatively simple concepts. Special relativity says a lot of things, but one thing it says is that information can't transfer at a rate faster than the speed of light. And so if you think of 2 events that are space-like, that simply means that they are so far separated in space-time that information can't have traveled from one to the other at the speed of light. So you would have to have superluminal signaling for that to happen, and there's no evidence that that happens. And time-like separated simply means the opposite, that the events actually are related in a chronological order to each other, and that one of them did happen before the other, and so information can travel from one to the other. And then the other word, by the way, is light-like, and that just means going at the speed of light. So I'm going to show, I hope, that in both cases, a person will experience exactly one stream of consciousness and will not experience more than one. Now, before I get to that proof, I need to point out another very important fundamental mistake that a lot of people make about consciousness. There's a lot of question about whether quantum mechanics plays any role in consciousness. There are a lot of people who think that, well, it's kind of a macroscopic system, so really we should be able to model it classically. And also, it's wet and hot. You couldn't sustain quantum superpositions in the brain for very long. Although Dr. Penrose is kind of working on this problem, but and all that may be true, and it may very well be true that most of what happens in the underlying physical state that produces consciousness, it can be modeled classically. But it doesn't change the indisputable fact, that quantum mechanics does affect consciousness. I'll just give you a very simple example. Somebody is walking around with a Geiger counter, and a Geiger counter is just a device that whenever it receives a radioactive particle from a radioactive decay, it'll click, and it does this by amplifying the event into something larger and larger until eventually it turns into a click that becomes audible. So when a person is measuring a uranium sample and that person hears a click, that person has not directly measured an alpha particle coming off of a uranium atom decay, but rather has measured some amplified causal chain of events that resulted from that fundamentally quantum event, because radioactive decay is a quantum event. So that's an example of a case in which that person's conscious state, that conscious awareness, is indeed correlated to some quantum event. Now, hearing a click may not be especially interesting from a quantum perspective, but what if that click, whether or not the person receives a click in a certain period of time, results in a big red button being pressed that causes World War III, or not? Well, then now, I mean, clearly that has a very strong resulting conscious correlation. And that's my whole point. I mean, there's lots of examples in which quantum events do and must have resulting conscious correlations. So that's an important point to note as we move on to the next screen. So the first thing I'm going to do is consider space-like separated particles. So first of all, imagine, I have this little cloud here. I'm no expert at what is this program? Microsoft, I don't know, the presentation program. What is it? Okay, clearly if I can't think of the name of it, which is Microsoft PowerPoint, then I'm not an expert in it. So this is my terrible animation here. And what this cloud represents is the underlying physical state from which some conscious state, call it C1, arises. We assume it's the brain. We don't know. It doesn't actually matter for the proof. It probably is, but the point is that that cloud represents the underlying physical state, and then the C1 is the conscious state that arises from it. Okay, so let's say at this time, and what do I mean by time? I really mean at this event in space-time, and I've shown that by, this is a light cone. If you're not familiar with it, it's pretty simple, but essentially anything that, once this event happens in space-time, anything outside of this light cone is a space-like event, and anything inside would be a time-like event. So anything that happens outside this cone, there is no fact about whether or not that event happened before or after this event. There's no such thing as simultaneity when you're outside of this light cone, but inside there is such thing as time chronology. So, so let's say at this time, this point in space-time, whatever physical system created that conscious state is dismantled or destroyed or something, but we still have the information about it. And so what we're going to do is we're going to take apart that, let's just assume it's a brain. We're going to take apart that brain, and then some later time, we're going to put it back together. And I have shown this over here. And so what this means is that it's later in time, but it's also, so we've gone up in the time component, and we've gone also over in the spatial component. Let's say just the x direction. We're only going to use one spatial component when we talk about these light codes. So the point is, let's say this happens 1,000 years later and 100 light years from this point. We put everything together. We recreate the exact same physical state as existed earlier, and I would argue, I hope you would agree, that that should and must create the exact same conscious state C1. It must, and that's kind of, that results from physicalism, which is the assumption that everything is physical and that consciousness must be fundamentally describable physically. And so if that's true, then whatever physical state created that conscious state, if we take it apart and put it back together at some other time, it has to be the same conscious state. All right, so now let's say this person then experiences some stream of consciousness to some later state, C2. And by stream of consciousness, I mean that in the colloquial sense. I don't know whether it's discrete or continuous or anything like that. It's just, but you understand what I mean. There's just some sort of, maybe there's lots of snippets of consciousness between them, or maybe it's continuous. I don't know. But the point is, this person experiences some flow of consciousness from C1 to C2. Now, I'm also going to show the light cone from this event, because what I want to do is I want to create a space-like separated instance of the same thing. And so I'm going to put that at some other place here, and notice I've put the light cone for that system, and notice that they are space-like to each other. And what that means is it is not the case that this event happened before this event, or vice versa, because there is no simultaneity in these two cases. However, notice that both of them are time-like to the original event, and that's necessary because when we destroyed this and we're trying to get information about it, well, we need that information to be used to make those later states. So we use it to then create this state and then also this state. So these are both kind of downwind from this point in space-time, but they are space-like to each other. I hope that makes sense. So now let's imagine that this, once again, this is the exact same physical state that created this conscious state has to create this conscious state. So that person then experiences some stream of consciousness to let's just say to the same state, to C2. So we've already figured out that there has to be some, whatever this person felt going into this state, and maybe I didn't make this clear, but if it's the same conscious state from here to here, then whatever this person is experiencing, they may not even know that their brain was taken apart and then put back together and made again later. That person should experience in what would seem like a stream of consciousness going to this C1 and then through this C1 to this C2. I mean, there may be, I don't know, some blink or some, maybe like when you go to sleep and have a deep sleep and then it feels like a second later and you wake up. But the point is that there should be some flow from here and through there. It's the same person. It has to be the same person because it's the same physical state. Well, that's true also of this, right? It's the exact same physical state. We've assumed that you can make a copy or two copies. So it has to be the exact same person who experiences going from here through here. And that seems odd, right? It seems odd that a person's identity would arise from both of those streams of consciousness. But that actually turns out to not be a problem because they're the same. They're the same stream of consciousness. So it really doesn't make any difference whether we say the person's identity or sense of self arises by going through here or through here. It's the exact same one. In fact, if we think of it, have a thought experiment in which for some reason that first one doesn't complete, maybe it gets killed or taken apart or something, but it doesn't complete, then it shouldn't change the conclusion that the person is the same person experiencing this stream of consciousness from C1 to C2. Now is where we get into the difficulty, and that is this. Let's say that instead of C1 naturally evolving to C2 because its underlying physical state evolved from some S1 to some S2, some quantum event happens and causes the underlying physical state to change. And then it now evolves into some different conscious state. I've listed it as C2 prime. But then notice there's no relationship between C2 prime and C2. I could have called it C3. But the point is that these are now different streams of consciousness. And that leaves us now with a question. And that is, well, which stream of consciousness does the person actually experience? Let's consider neither. Well, okay, so as soon as some quantum event happens here, that screwed everything up, and now the person's dead. The stream of consciousness just ends. But the problem is, just as these two events are space-like to each other, this quantum event also is space-like to this stream of consciousness, which means that there's no fact about the simultaneity, and there's no way that this system could know about this quantum event until after the stream of consciousness has already been experienced. So special relativity gets in the way of option A. So it can't be neither. All right, well, maybe if the person had previously experienced both streams of consciousness, right, from going from C1 here to C1 here up to C2 and also up to C2, that was fine. They were the same stream of consciousness, but maybe here, now that they're different streams of consciousness, the person still experiences both of them. I don't know what that would feel like, but just say, that's the case. Well, you probably have realized by now that also violates special relativity because whatever stream of consciousness or whatever conscious state this person experiences at any point along here depends on the underlying physical state. Right? The underlying physical state is what made the emergent conscious state, or ultimately that conscious state depends on that underlying physical state. So once again, we have a problem because whatever conscious person is experiencing this stream of consciousness is doing so based on some underlying physical state. But that physical state is space-like separated from this physical state, which means that that person can't also experience a stream of consciousness from the evolution of this underlying physical state at the same time. There's no simultaneity in these two space-like separated events. And the same person here obviously can't experience what it's like to go to conscious state C2 as opposed to conscious state C2 prime, because that depends on the underlying physical state here, which is space-like separated from this physical system. So it can't be both. So if a person experiences something, it can't be no stream of consciousness. It can't be both. So the only thing left over is that it experiences just one. So that essentially is the proof of the single stream of consciousness theorem for space-like separated instances of the same conscious state. Well, what about, okay, well, what if the two instantiations are time-like separated? Well, it's actually a similar argument. Goes like this. Again, we start off, this person has experienced a series of conscious states leading up to this event, this moment in space-time, shown by this light cone. And then that state is destroyed, but the information about it remains, and so we recreate the exact same physical state at some later time. And of course, then that will evolve to some state C2, and then this is the light cone for that event. But now, this time, we're going to consider another copy that is time-like separated to this. That is, it could be causally related to this event right here. So we're going to put it there within the time cone of this event. And so then it evolves, let's say, to the same state, conscious state C2. we don't have a problem, just as we didn't have a problem before. What does the person actually experience? Well, without this, the person experiences some stream of consciousness getting to here. Maybe that person experiences a blip of some sort, but then, is conscious again here. Maybe there's no blip at all. Maybe it's a seamless, continuous flow. I don't know, but it's the same conscious state. It has to be the same person. So there's a flow. That person will experience C1 to C2. Now, is it caused by this stream of consciousness or this one? Well, it doesn't matter because, again, it's the same stream of consciousness. So there's no conflict, there's no issue. Again, if we say, okay, we're going to create it here and then instantly destroy it, but then create it later, again, there's no problem. The person still experiences a stream of consciousness from C1 to C2. Now, the problem, as you surmise, is going to be when now instead of it flowing to C2, some quantum event happens and it flows to some different conscious state, C2 prime. And now this is where the argument becomes a little bit different. You might say, oh, well, there's no problem here. All that happens is a person experiences this stream of consciousness from here to here. And then afterward, the person experiences another stream of consciousness from here to here. Here's the problem. This and this are the same conscious state. A conscious state has a lot, I don't know, we don't know exactly what a conscious state is, but, one thing I do know about it, I know that I'm experiencing a conscious state right now, and I know that it's related to the concept of now. Okay, so that state that I experienced a few seconds ago, that's gone. I'm experiencing a new conscious state that feels like now. So every conscious state has this notion of now to it. And it doesn't really matter when it happens, right? I mean, like this person could have been, the brain could be destroyed and then recreated a million years later, and that person might not know a million years have passed. Rip Van Winkle might not have known that 20 years have passed, but the point is that that same conscious state still experiences the same concept of now. And what that means is that whoever this is, it's the same person experiencing the same conscious state, they have to experience the same concept of now. So what is it like to experience this stream of consciousness subjectively at the same time as this stream of consciousness? Because these two are the same state with the same concept of now. Well, the only way, okay, so then let's ask the question. Which stream of consciousness is actually experienced? First, let's say neither one, because once this happens, it screws up everything and the person can no longer experience anything. Well, that's problematic because we don't know for certain. Notice I put C1 after this C2 prime. We don't know for certain at this point whether or not there actually will be this copy C1. We don't know for certain. And so that must mean, so if we say that the person doesn't have a stream of consciousness at all, then that would mean that whether or not the person experiences a stream of consciousness depends on the truth or falseness of some future event. So we have backward causation. Okay, so that's a problem. So that can't be true. So maybe, again, the person experiences both streams of consciousness. But again, because it's the same conscious state from the person's subjective point of view, they're experienced at the same time. But how would it be possible to experience, I mean, assuming you could experience multiple streams of consciousness, I don't know what that would be like, but assuming you could, what would it be like to experience this stream at the same time subjectively as this stream, even though this stream depends on an underlying physical state that hasn't happened yet? That evolution hasn't happened yet. So the only way to experience these subjectively at the same time is, again, to rely on backward causation, which we think is probably a problem. So it's not both. The person does not experience both. So that means that it can only be one or the other. So, in other words, whether or not we consider time-like separated instances or space-like separated instances of these copies of conscious states, at the end of the day, if a person is conscious and experiences some stream of consciousness from that conscious state, that person cannot experience more than one. So that is the proof of the single stream of consciousness theorem. Now, what is the result? What is the implication? Well, one implication is that a conscious state just can't be copied at all, and it can't be repeated. And that can be shown easily. It's kind of similar to the earlier proofs. It's a little different. So, there's some underlying physical state that creates some person's conscious state C1, and that evolved to some later conscious state C2. So now we just assume that we can copy that state. Just assume we can copy it, and then we'll create that copy. We'll instantiate that copy, and then now let them both evolve. But then, because of quantum events, and we know that conscious states do correlate to quantum events, then let's just say that there's some quantum randomness, which there probably will be, and that results in them evolving into different conscious states, C3 and C3 prime. And that would mean that this person experiences multiple streams of consciousness via that conscious state C2, and that violates the single stream of consciousness theorem. It is not possible. Weird. It also implies that consciousness cannot be algorithmic. So, what is an algorithm? An algorithm is just software. It's just a set of instructions that takes an input to an output. And interesting fact about it is that it is very easily copied. You can reset the execution of a software program on the same computer, or you can make a copy of that algorithm, run it on a different computer, or 1,000 or 1,000,000 computers, and it doesn't matter where they are in space and time. You can run the same algorithm on a completely different computer made of Tinker Toys 20 light years away, and if consciousness is algorithmic, then that shouldn't make any difference. So if consciousness was independent of inputs, then there isn't necessarily a problem with algorithmic consciousness, because it's just deterministic. If that conscious awareness doesn't depend on the inputs, or if those inputs are themselves deterministic, then we don't necessarily have a problem, because we won't necessarily have that diverging stream of consciousness. But we already know that at least sometimes consciousness does correlate to random quantum events. And so, if that's true, if consciousness were algorithmic, then that would necessarily result in diverging streams of consciousness, and that would violate the single stream of consciousness theorem. Another way of saying it is, if a conscious state cannot be copied, which I just showed, but an algorithm can be copied, then an algorithm can't produce a conscious state. That's what I've got for you, but I also wanted to spend a few minutes talking about some objections and some questions, because there's going to be lots of them. I can't address all of them, and I'm very much interested in your comments to this video, what other questions and objections you might have. But here's a couple of them to at least show that I've thought about them. Well, Andrew, what the hell is conscious? What does that mean? What is a stream of consciousness? I don't know, but nor does anyone else. What I do know is that I am conscious, and I do seem to experience some stream of consciousness. I just mean that, again, in the colloquial sense. I just, this moment seems to have, come immediately after the last moment, and so forth. And, when I go to sleep, sometimes there are, discontinuities, but again, I don't necessarily know what these mean, nor do I have to know what they mean. It's just, if there is if an entity is conscious and does experience some discrete or continuous stream of consciousness from that state, then the theorem simply says that it can't be more than one. That's all. This objection I get from philosophers, which means, and I get it all the time, which means that either I'm missing something fundamentally, and maybe I am, or they are. And it's this argument that, hold on a second, I've made this assumption that two instantiations of the same physical or conscious state create the same person. And that's not necessarily true. And there's this notion in philosophy of whether these two physical or conscious states are numerically identical. And you might just object to the entire proof and just say, well, you didn't create the same person. But that objection moots the entire issue. And what I mean by that is, let's go back to the teleportation problem, right? The problem was, what happens if, I make an exact copy of myself, my brain, my physical state on Mars, and then this version is destroyed. Would I experience, being on Mars? Would I be teleported to Mars? And what would if I was, then what would happen if this version on Earth wasn't destroyed? Well, if you don't think that that copy on Mars is me, then the problem of multiple versions of me doesn't arise in the first place. And that's the same for every single problem that I mentioned earlier, and every problem that kind of results from this field. If there is no recreation of the same person in the same conscious state, then you don't have a problem. The problems arise when it's the same person that results. Next one is the many worlds interpretation of quantum mechanics. I actually wrote a paper about this, and maybe I'll post it on my website at some point. So I don't want to spend too much time on this, but essentially, many worlds kind of depends on this notion of splitting into many streams of consciousness because of this notion of branching, although Max Tegmark would say that there really isn't, it's not really many worlds because those worlds could ultimately re-interfere with each other, et cetera, et cetera. But ultimately, there is a real identity problem in the many worlds interpretation of quantum mechanics. But the reason I also don't want to spend too much time on this is this. It's an interpretation that I would argue, and many would argue, is not currently formulated in a falsifiable way. There is no many worlds hypothesis that can be empirically tested now or probably ever. And so I don't think that makes it a scientific question at all. It really is. This is the philosophy of the problems in quantum mechanics, and there might be the Copenhagen interpretation, and there's the objective reductions and all kinds of different ways to. Quantum mechanics has lots of problems, and so this is kind of one way to deal with it. But it's an interpretation that I don't think, at least right now, is an empirically testable issue, and certainly has not been proven to be true. So I don't think that's a valid objection. Another objection might be, well, why am I using physics to think about consciousness? Well, most people who are currently studying consciousness in an academic way are looking at, neurobiology. They're looking at the brain, and that's fine. And I think that we have made huge progress, and we will continue to make huge progress from that point of view. The problem is, I think, is that I think if you can understand something from the underlying physical realm, then that whatever you figure out is going to be kind of more true in some sense than what you. That sounded condescending to other fields. Biology is a very useful field, but biology is maybe an approximation of chemistry. And chemistry is a very useful field, but that probably is an approximation of physics. Physics, I think, aims to be what is ultimately happening. Those are the laws of nature, the unbreakable laws of nature. So if we can understand anything about the hard problems of time and cosmology and free will and consciousness, if we can understand them from physics, then I think we should, and that's the approach that I have taken and will continue to take. And then a related question is, well, come on, maybe at best this is just philosophy, and at worst it's just pseudoscience, it's just crap. And that's certainly what many people will say. Many of the greats of physics had these questions and thought that they could at least ask them and try to answer them. I think that we can ask them and try to answer them, and I don't think that automatically makes it not scientific. And in fact, I think that applying everything we know about the laws of physics to answer these hard questions is, by its very nature, scientific. So I certainly don't think there's anything pseudoscientific about asking these questions. I mean, you certainly can get confused about, the energy in the universe and quantum blah, blah, blah. And the word quantum is thrown around a lot in the pseudoscience community. And so there is worry about that. But I don't think that these questions that I'm asking and how I'm approaching them is pseudoscientific. You may disagree. And also, I used to think this was really just philosophy of physics. After reading lots and lots and lots and lots of books and articles from the philosophy standpoint, I don't think it is. I think that the questions that I'm asking and trying to solve can be addressed by looking purely at physics, and that there are objectively correct answers. We may not know them yet, but there are objectively correct answers to those questions. And now this is an interesting question, and that is on entanglement. Entanglement deals with events that seem to not be local. So, for example, if two particles are entangled in a particular way, then if one particle is measured and you get some certain result, and the other particle, which may be separated from the first particle by some, they're space-like to each other, maybe it's a million light years away, and that second particle is measured in the same way, in the same basis, then the outcomes of those measurements will be correlated, which is to say that the quantum events, whenever we measure them, the outcomes seem to be random according to certain distributions. And so that first outcome, what does first mean when they're space-like separated? But that first particle, when we measure that first particle, however it's measured, it's blue or it's red or it's up or it's down or whatever it is we're measuring, that outcome is going to be random based on a probabilistic rule of quantum mechanics. And if this second particle if they weren't entangled, then we would make a measurement on the second particle, and it too would be random according to a similar rule. But if they're entangled, then it turns out that the randomness of that second particle melts away, and they'll either be the same or they'll be different or whatever. But it'll be once you know the result for the first particle, you'll know the result for the second particle. And it's very weird. We don't really understand that either, because does that mean that the first particle sends a signal to the second particle, but then it would have to go faster than the speed of light? And anyway, so we don't really understand entanglement either. But you might just say, well, can't just entanglement just solve this problem? Like, I've been assuming, I came to the conclusion that you can't copy a conscious state, and that was because basically those two conscious states could diverge into different streams of consciousness, and that's going to be due probably to some quantum event, some random event. But if those two states are perfectly correlated to each other in every way, well, then maybe it can never be that one experiences, one quantum event and the other one experiences a different outcome or a different quantum event. So maybe there's no problem at all. Well, there is, because if you could ever copy, to copy two brains, to copy a brain and make a perfect enough copy such that they are always perfectly quantum mechanically correlated would require a copy so perfect that it violates the quantum no-cloning theorem. So that issue goes away. So kind of finally, I just want to, I think a very serious objection might be, come on, get serious. I mean, okay, this, I hope, was an interesting talk, but it can't be right. I mean, it's obviously wrong, right? This, nobody's going to take this seriously because it's obviously wrong. Right? Did I just prove that you can't copy a brain? Well, of course you can. We're working on it right now. You know, you can't copy a. Of course you can do this. I mean, of course the brain is a computer. It's algorithmic. Someday we're going to be able to upload consciousness onto a computer. We know that, right? But we don't. They, as I pointed out earlier, they're just assumptions of physicalism. And in fact, there's very, very little evidence, if any at all, that the brain is algorithmic. Or acts algorithmically. There is no evidence that a conscious state can be copied. They're all kind of thought experiments. So I think the reason that so many people cling to this, other than kind of the coolness factor of someday I'm going to upload my brain to a computer and live forever, other than the coolness factor of it, I think that a lot of people are very afraid, scientists are very afraid that by getting rid of these assumptions, not making these assumptions, that we allow dualism, that we allow God or religion into the scientific picture. And there's nothing wrong with being religious, but if you're going to ask scientific questions, let's leave it to the realm of measurement and being able to make physical predictions and testing hypotheses, etc. But the fact is, as I pointed out earlier, we don't have to get rid of physicalism to get rid of the assumptions that the brain is algorithmic or it's a computer or that conscious states can be copied. We don't have to take those assumptions while still believing that everything, including consciousness, is a physical result. And kind of on that note, we already know for certain, well, certain as we can be, that if copying a conscious state requires a level of copying of the underlying physical state that is so good that it violates quantum no cloning, well, then we already know that from a physical standpoint, physical viewpoint, it's not possible. So, so then that leaves the question: if I'm right that a conscious state can't be copied, and that consciousness is not algorithmic, and that a computer will never be conscious, and a Boltzmann brain will never just randomly appear in a million years, you know, to create my consciousness. If that's true, then what are some of the deeper implications of that? How might that affect questions about black holes or free will or information or cosmology or the direction of time? And I think that there are implications for those, and I've just begun the work on it. But if you have any ideas or thoughts, or again any other objections or questions, please leave a comment. I'm very, very interested. And then finally, here are a few of the references that I mentioned in this talk. There are lots and lots of great papers and books out there addressing this, but here's just a few of them. So thank you so much for your time and for listening, and very interested to get your feedback.